Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding Shine-Dalgarno sequence. Is it okay? So what is Shine-Dalgarno sequence or how we can define the term known as Shine-Dalgarno sequence? So Shine-Dalgarno sequence or it is otherwise termed as ribosomal binding site. Is it okay? So let me write it here. Ribosomal binding site. Ribosomal binding site. Is it okay? So as the name itself suggests, ribosomal binding site, that means this is the specialized site where exactly the small subunit of the prokaryotic ribosome, it gets successfully recruited to the mRNA. So as we all know, during the initiation phase of the translation mechanism, the small subunit of the ribosome, it has to recruit to the mRNA or it has to recognize the mRNA. In order to recognize the mRNA or in order to recruit to the mRNA, the small subunit of the prokaryotic ribosome, it takes the advantage of a specialized site and it is nothing but what? Ribosomal binding site or Shine-Dalgarno sequence. Is it okay? Now here my question is, how the small subunit of the prokaryotic ribosome it is capable to recognize the Shine-Dalgarno sequence or the ribosomal binding site. So in order to recognize the Shine-Dalgarno sequence or the ribosomal binding site, the small subunit of the prokaryotic ribosome it takes the advantage of a specialized RNA sequence and it is nothing but what? 16S rRNA. The specialized 16S rRNA which is embedded in the small subunit of the prokaryotic ribosome, it is responsible for recognizing the Shine-Dalgarno sequence. Is it okay? So let me present it here. So let us assume it is the 5' end of the prokaryotic mRNA and here there is an availability of ribosomal binding site. Ribosomal binding site, simply termed as RBS. Is it okay? So very adjacent to the ribosomal binding site, here there is an availability of start codon or the initiation codon. Start codon or the initiation codon. Start codon or initiation codon. And here it is nothing but the normal mRNA, right? And here there is an availability of stop codon or the termination codon. Stop codon. And it is the extreme 3' end of the prokaryotic mRNA. Is it okay? Now, so during the initiation phase of the translation mechanism, the small subunit of the ribosome, it has to recruit to the mRNA. Is it okay? So in order to recruit to the mRNA, in order to recognize the mRNA, the small subunit of the prokaryotic ribosome, it takes the advantage of ribosomal binding site or Shine-Dalgarno sequence. Is it okay? But now here my question is, in order to recognize the ribosomal binding site or Shine-Dalgarno sequence, the small subunit of the prokaryotic ribosome, it takes the advantage of a specialized RNA sequence and it is nothing but what? 16S rRNA. So by taking the advantage of 16S rRNA which is embedded in the small subunit of the prokaryotic ribosome, the small subunit of the ribosome, it is capable to recognize the Shine-Dalgarno sequence or the ribosomal binding site. Is it okay? So let us assume it as the small subunit of the prokaryotic ribosome and here the 16S rRNA is embedded. And if you look at the specific ribosomal binding site or the Shine-Dalgarno sequence, the specific ribosomal binding site or Shine-Dalgarno sequence, is it okay? The specific ribosomal binding site or Shine-Dalgarno sequence, it is a series of 6 to 7 consonance nucleotide sequence which is present at the extreme 5' end of the prokaryotic mRNA and it is present just 2 to 3 nucleotides away from the start codon or the initiation codon. So this is nothing but the start codon or the initiation codon, right? So right from the ribosomal binding site of the Shine-Dalgarno sequence, the start codon is present just 2 to 3 nucleotides away. And if you look at the specific consonant sequence, which is a part of the Shine-Dalgarno sequence, the specific Shine-Dalgarno sequence, it is rich in A, G, G, A, G, G, U. Is it okay? So this is nothing but the Shine-Dalgarno sequence. Shine-Dalgarno sequence. And here the complementarity nucleotide or the complementarity nucleotide sequence of the Shine-Dalgarno sequence, it relies in case of the 16S rRNA, which is embedded in the small subunit of the prokaryotic ribosome. Is it okay? So let me present it here. So let us assume it has the 3' end of the 16S rRNA. So the complementarity of A is U, G is C, G is C, again A is U, G, C, G, C, U, A. And it is nothing but the 16S rRNA. So by taking the advantage of 16S rRNA, which is embedded in the small subunit of the prokaryotic ribosome, the small subunit of the prokaryotic ribosome, it is capable to recognize the ribosomal binding site or Shine-Dalgarno sequence. Is it okay? So here we need to understand two important strategies which govern the translation mechanism. The accurate base pairing in between the 16S rRNA and the Shine-Dalgarno sequence, it plays a prominent role in organizing the translation mechanism. If there is no accurate base pairing in between the 16S rRNA and the Shine-Dalgarno sequence, under such condition, the translation mechanism or the translation process, it is unable to proceed forward. Is it okay? Accurate base pairing in between the 16S rRNA and the Shine-Dalgarno sequence, it plays a prominent role. And in addition, successful recognition of the start codon or the initiation codon by the small subunit of the prokaryotic ribosome, it also plays a prominent role in organizing the translation mechanism. Is it okay? So there are certain inhibitors which inhibit the translation mechanism by inhibiting the accurate base pairing in between the 16S rRNA and the Shine-Dalgarno sequence. So under such condition, the translation mechanism or the translation process, it is unable to proceed forward. So this is regarding the Shine-Dalgarno sequence or the ribosomal binding site, which is a part of the prokaryotic mRNA. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.